All right. So welcome to episode 3 of our IC tutorial. Now, this is probably going to be the first like real sort of practical IC10 script because we're actually going to automate the solar tracking, and we're going to show sort of how easy it is using the IC chips. So normally with if you were to set this out with logic chips, you'd need like 2 logic readers, you'd need 2 batch writers, you'd need 2 logic maths, and you'd need at least 1 memory. Just to get like, so you need that many, like basically 7 chips to do the automation of um, yeah, the automation of solar tracking. And we're actually going to do it. You can do it with just one IC chip. So so that's the plan for today. I just realized we don't have we need a sensor for the daylight sensor. So, and the other thing that's a little bit different with the solar tracking is, or the solar power, is that you gotta sort of set up your power network quite specifically. So what we'll do is this. So this is a transformer. You don't need a transformer. This is just it. When I turn this power, when I turn that, the power goes off. Right. So this is just how I can stop the rest of my base power from impacting this area once we're set up. Just to sort of show how it all works. So the good thing about the IC housing is that it's built for solar, like it's built for separation of networks, because you can see that there's 2 types of IC housings you can use. You can use the single or the dual. So in this case, we want the dual, and what we want is we want the power to be on the battery side, and we want the data port to be pointing to the solar arrays, which is what this setup is here, right? So that means that this chip is going to get its power from over here, but it needs to talk to things over here. Um, and the other thing we need to do is we sort of need to separate this network, the power generation network. So we want the power to be coming from the solar panels into this little area power controller, and then out along this. And the reason we want this is that when the sun goes down, if you don't have some form of battery that's sort of powering your solar panels, they actually will stop. They won't rotate. Um, so yeah, so this is the basic setup that we're going to do. So we will just turn that on. Now, the other thing that's important when you start talking about solar panels is the orientation is really important. So what we want, so and the other thing is there's 2 different types of solar panels. So this is solar panels dual, and then there's solar panels. So there's solar panels where the power and the data is all on the one port, and there's one where the power and data is separate. So we're going to build one of each, just so that I can show you why it's actually important. So here's a solar panel dual, and we'll do a solar panel where everything's on the one panel. This here is meant to be the sensor. And what we're doing, we're making a deliberate choice. If you look down the bottom right, we're pointing the power, we're pointing the power to 90 degrees. So the orientation is important. And what's important is this daylight sensor, which we also need. Its power port also needs to be pointing 90, or its data port needs to also be pointing 90. So the orientation of that daylight sensor is also important. And there's also solar panel heavies. So there's solar panel heavy dual, and here's the solar panel heavy. All right. So these are the 4 types of solar panels that exist in the game. And you'll see why it's important as we build our script, but I just wanted to get it set up like that. All right, so we don't have a chip selected, so we need to throw the chip in as per normal. And actually, the reason it's doing this is because it doesn't have access to the IC housing data port. So we're actually going to need to temporarily make it a dual on this side, because the computer couldn't see the data port, and which is why we're getting that error. All right. And from our previous lesson, we want to do we'll do the IC house, and we'll call this solar tracking. All right. So now that we've got a sort of base set up, let's dive into the script of what we're trying to do. So again, let's get our basic script happening. So basic script, we want to define define devices, and this is D0 to D5. We want to define variables, and this is R0 to R15. And we want the main loop. I'm not sure it's 15 or 16. So our main loop, we'll go start. We'll go jump to start. So this is pretty much how we're going to start every script. So now the devices that we're going to use for this IC script, the only one we actually need is the daylight sensor. So we want to go alias. We'll call this sensor, and we'll put it on D0. Right. Because the devices, the thing about the devices, right, the reason why we don't put the solar panels on here is that you've only got 6 screws, right? So one of them has to be the device, and if we wanted to connect them up, we could technically connect them up to using these device screws, but we'd only ever be able to have 5. We'll only ever be able to have 5 like solar panels hooked up. There's a command in IC programming, much like the batch writer. It's called save batch. Right, so SB is, so S is where you save it to a specific device. SB is save batch, and this is where we'll do all solar panels, right? So that's basically the plan. All right, so let's walk through the code. So what we want to do is we want to read the vertical from sensor. We want to read horizontal from sensor. Right. We want to apply offset to vertical and horizontal, and then we want to batch write to all solar panels. Right, so this is the general script, and I think trying to mapping it out like this, I think it is, will help you out, because comments don't compile, right? So read vertical from sensor. So what that means is the variables. Well, now we need a vertical, and we'll put this in R0. Right. So we're going to read a vertical. We're going to read horizontal. So we can go alias horizontal from R1. The offset will come back to, and then we want to batch write to all solar panels. So what we can let's just get this started for now. Okay, so read vertical from sensor. So if we look at if you remember from our previous 2 episodes, it's literally as simple as we want to use the L command, so load vertical. So we want to save it into vertical. The device is the sensor, and the logic type. So if we press F1 and we go and we search for the daylight sensor, right, and we have a look. So there's a few that we have here, and you can see that there's a vertical and there's a horizontal. There is also a solar angle. I've never had to use this. I'm sure that there is some purpose in using it, but we don't need to complicate it. All we need is vertical and horizontal. So the logic type is vertical, so that makes it pretty easy. So then we do the same for horizontal. So horizontal from the sensor, and the logic type is horizontal. Okay. Now we're not going to apply the offset, so that I can explain, so I can sort of show you how this thing works. And now we want to batch write to all solar panels. So instead of just using the save command, we actually want to do the save batch. Now it's asking for a device hash. So the way you work this out, again, you press F1 and we search for solar panel, right? Now, so here's our solar panel. So we click on that, and this prefab hash, this is the device hash. So what you can actually do, you can just click on this actually, and it copies it to clipboard. And then we can just, so the device hash is this, right? The logic type that we're writing, well, we got to do, again, I guess we can have a look what logic type there is. So the logic types that exist on the solar panel, you've got the horizontal and you've got vertical. So let's just write like, okay, so in the vertical, we want to save the vertical value, right? And so let's do the same for horizontal. So save batch, we paste that, we go horizontal, and we type that in, and that's it. This is your automated solar tracking, right? It's not going to work because we haven't done this step here, but I want to let me show you why that one's important. So confirm that. Now, how can we? The challenge we have. Actually, this might be a good idea. This might be a good to show. This might be a good idea to show the sort of the way that I set up my normal setup, right? Okay. So what we're going to do. So remember, with the way we want the solar panels to go, we want the data port to be pointing towards the solar panels, and we want the power to be coming from, like, you know, the battery. But the problem is, because this data port is over here, this computer can't talk to it. So what I normally do when I'm doing IC programming, what I normally do is I call this one like, hey, you know, IC housing dev. Right? Now the reason I do that is because this list is alphabetical. So if you walk away from your computer and you come back, it actually sorts back to the most alphabetical one. So what I'll normally do is I'll have a dev IC here, and this is where I do all my programming. And then once you export it to the chip, you can just take that chip, put it there, and it will run. So the chip is what actually has the program on it. It's not the housing. So and this is sort of how I do my typical setup. So look, so if we go back into the script, right? So you can see this script is actually super basic, right? We read from we've got one sensor set up, we've got a horizontal, we've got a vertical. You know, we're loading the horizontal, or we're loading the vertical, we're loading the horizontal, and then we're saving it to or we're batch writing it to the solar panels. Now, there is a command to set the sun if you're in creative. So if we go orbit set 0.5, this should take us to midday-ish, or at least, okay, the sun's coming up. That's the point. And unfortunately, my wireless battery is charging. But anyway. Okay. So I've got that. So let's export this, right? So we export this, which puts it on the chip, and then let's put the chip in there, turn this on. It's going to want us to put a sensor here, and there's a daylight sensor. So if we have a look at what's happening, right? So we are reading the value from this daylight sensor, and we're just writing it to this solar panel. And you see how we're doing a batch, we're doing this batch write, but we're only targeting this particular solar panel, and it's actually just this solar panel. So there's actually multiple. So if you have a look at solar panel dual, this is a different hash, right? So the solar panel dual hash is actually different. So this is the solar panel dual hash, right? We'll just save that. Let's just have a look here. So this is currently our solar panel, and you can see it's not exactly lining up with the sun. Let's give these things some some glass sheets. So you see how this is not lining up with the sun, and this is because of the offset. Now there's a few ways you can modify the offset. One of them is to actually to move this sensor. So if we were to move this sensor and make it face a different direction, right? Let's just set up for the eventual, because one of these probably works without offsets. Let's have a look. So if we were to set this up, so see how the power, so normally I make the power align with the solar panels. If we make it face this way and we load it back into the device, all right, let's see what it does. See, it's still not quite. Now it's gone the opposite direction, right? So the orientation of this daylight sensor is really important. Let's try this side, and let's align it. Let's have a look what that does. I just wonder if one of these actually works. Eh, not really. See, it should be at 99%, right? This is sort of tracking it, but it's not perfect, right? And if we do the final check, which is this one here, and we align it in the okay, and you can see that it's going like some completely different direction, right? So yeah, it's going completely Burko. Okay, it's pointing this way. So there's no orientation of this daylight sensor that, well, someone's probably going to correct me, but at least on this plane, maybe if you go vertical, I don't know, maybe you need to change the setting on it. But the point is, you can see how the orientation of the sensor actually impacts your script. So all my scripts, I put it so that these cable ports, they all point the same way. And what's most important is the power. So as long as the power is all pointing the same direction, and that direction is 90 degrees, that's pretty much how I set up all my scripts. You can do it with any direction. It's just your offset is different. So let's set up this. Let's connect this. So this is the proper This is the proper setup. Now, the one thing we're actually going to do is we're going to go orbit timescale 0. Now, I believe at orbit timescale 0, that pauses the sun. So we can clearly see that without modifying the offset at all, we're not getting the, like, it's not pointing towards the sun. So we've got to add some form of offset. Now, the reason I point everything to 90 degrees is that I already know that the offset that we need to add is 90. And we can do that by using the add command, right? So if we add, I wonder if we can go add vertical 90, add horizontal 90. So if we put that here and we export it and put that back here, oh, I see. So it goes over the top. Right? So by adding an offset of the vertical 90 and the horizontal 90, that's what it was. Yeah, okay. So we add 90, that means it's only minus 70, and minus 70 from 360 is basically 290. Right. So I've actually flipped over. So the solar panel is flipped over as well. Right. That's why the maths makes sense. Okay. Okay. It's all starting to make sense now. So yeah, so in this particular case, adding 90 to the vertical and the horizontal and saving it to the solar panels makes it so the solar panel moves. Now, as you can see though, it's the only solar panel. These are all solar panels, but the problem is they're different device hashes. So if we want to move this one, we actually need to add the device hash. So we already checked. So if we go F1, the solar panel dual hash is this, right? So we do the same thing, save by hash. Copy that. We go to vertical, and we do vertical, right? And save batch, horizontal, right? We confirm that. So we put the chip here, we export it, put the chip back, and we should see this solar panel now goes and takes action. Right, so it's now at effectively 100% basically. And so now we've got the heavy solar, so we've got the solar panel heavy dual and the solar panel heavy. So let's do the same thing in here. So we press, so I mean what you could do this, right? You could go define solar panel hash, right, as this, and then we could replace it here, right? Then you could do define solar panel dual hash. And you can put that here. All right, and this is probably the better way to go. So you get a solar panel heavy hash, and we've got the define solar panel heavy dual hash. Right, so the way we work this out, search for solar panel, and we want the heavy. So solar panel heavy is this number here. So solar panel heavy is that. And the solar panel heavy dual, this one is this. Right. And then we go save batch. So we go solar panel heavy, vertical, vertical, save batch, solar panel heavy, horizontal, horizontal, save batch. We grab the next one, the dual, vertical, vertical, save batch, horizontal, horizontal. Right, so this define, it's different to alias in that you're basically just setting a value like straight away. I don't think, I'm not sure if you can actually change it after the fact. But this is just if you just want to set, you don't want to use one of these registers because you're just setting a value. So it actually means you're not using up one of these registers. All right, let's confirm this. So now we're doing the save batch, the solar panels, the solar panel duals, the solar panel heavies, and the solar panel heavy dual. So if we put the chip in here and we export it, and we put the chip back, we should see both of these now are going to rotate and do the same thing. Now, why this is so handy is, like, you're going to want to do more solar panels, right? So as you start building more solar panels, right, all you have to do is add them to the network, and they'll automatically be added, like, turn the right direction. So you add that there. Right. And so these things are now, yeah, they're just moving into direction. So the script is actually not that hard to automate just the solar panel hashes. Most important thing is the panels are all the right orientation. So the orientation of the panels matter. The orientation of the daylight sensor matters. And if you point them all to the 90 degrees, the direction 90 degrees, then the script math is pretty easy, right? You read the vertical from the sensor, the horizontal from the sensor, you apply the offset, which is 90 for both, and then you batch write to each of the different types of solar panels. And then lastly, you loop back around. Now, the one thing that we should add into this script is a thing called yield. So I think you guys are now ready for yield, right? And this is makes script run only once per second. Performance. Right. So yeah, so this is the script for basically automating your solar panels with IC. It's really not hard, and especially if you actually ignored solving it for every single solar panel, it's quite simplified. But I think just adding that extra information for you guys will help you in your automation journeys. And yeah, that's it. And just to show it, so you can, because the issue is obviously I've turned the orbit off. Oh God, what's the true time scale? what is the real time scale? Orbit time scale. Is it 1? Oh God, no, it's not. Orbit time scale 10. Oh God, orbit time scale 0.1. Okay. Okay. Good news is we've survived 107 days. Okay. Yeah, we're still not there. Orbit time scale. What is it? 0.01? Wow, it's still not orbit time scale 0.001. Okay, okay, that might be better. Okay, so yeah, so you can hear that. So you know the script is working because you can hear the solar panels keep turning, and their efficiency is close to 100%. You typically will get 99% is what I've found. It could be because they're so close together and there's that little bit of shadow. That actually does impact things. So you'll see this one is less efficient because it's right next to each other. So um, so yeah, it actually does matter when if you've got shade on, and on this one, this is my battery, my main battery. Yeah, I just space them out. So yeah, sorry, I'll turn that off. And yeah, so the concept is the power all comes into some form of battery, right? You need some form of battery, um, because what happens at night time is obviously there's no power and these solar panels will stop turning. So you've got to put it in some form of battery, and you've got to make sure the battery doesn't connect to itself, otherwise it basically the fuses will pop. So this is where the IC comes in, because this IC chip has a power on this side and a data on this side, and it's just perfect for separating the data network of the solar panels from the power network. So it naturally solves the battery problem. Yeah, so like here's an example, right? So we've sort of got no power anymore, um, but the solar panels are still moving because of the battery. So yeah. Anyway, that's the and so these will keep moving during the night. All right, they'll follow the sun. But if you didn't have this, right? So we take out the battery, these everything just stops, right? And what that will mean is in the morning, when the sun comes up at 90 degrees over there, um, these are going to be useless. They won't be generating any power. So you'll basically be power locked. So that's why you need this battery to make sure that the solar panels keep turning. But yeah, but this is the yeah, this is the episode 3 script. Okay, I'm just saving it so that I can grab it. All right, yeah. So get out there. So I think automation of power is like super important in Stationeers. Uh, everything requires power, right? You want to do fancy airlocks and atmospherics, you need like a lot of power. So you've got to have this thing automated so you're getting your so it's efficient, and you can just keep with things like this. You can just keep building them out, which is what makes it so powerful. So yeah, all right. Well, that's a wrap on episode 3. All right, we will catch you later.